Welcome to the DIY Honda Garage channel. DTC P2821 indicates a problem with the line pressure solenoid valve A, which is responsible for regulating the hydraulic pressure in the automatic transmission of your Honda Odyssey from model years 2011 to 2017. When this fault occurs, the vehicle experiences a fail-safe mode, which restricts engine torque to prevent further damage to the transmission components. This means that the vehicle might not operate normally and can exhibit signs of reduced power or shifting issues. Since modern vehicles rely on electronic controls, it is crucial to start the diagnosis using the Honda Diagnostic System, HDS, to capture freeze data and onboard snapshots. Understanding the context of the DTC, including the engine and transmission's performance, is essential for effective troubleshooting and repair. The line pressure solenoid valve A plays a significant role in controlling the hydraulic pressure in the automatic transmission system of the Honda Odyssey. This valve is located within the transmission assembly itself, typically situated near the valve body, where it interacts with the transmission fluid to manage pressure. The primary function of this solenoid is to adjust the pressure applied to the transmission's clutches and bands, facilitating smooth shifting and overall transmission performance. When it is stuck in the on position, this valve fails to modulate pressure correctly, leading to poor vehicle performance and engagement issues. In conjunction with the PCM, Powertrain Control Module, the solenoid ensures that the transmission operates effectively under various driving conditions. Several factors could contribute to the appearance of DTC P2821. First, a faulty line pressure solenoid valve A could lead to incorrect pressure regulation. It may malfunction due to electrical faults or internal mechanical failures. Next, issues related to transmission fluid may arise, such as low levels or contamination. If the fluid is not at the right level or is dirty, it can affect the solenoid's operation and overall transmission performance. Moreover, the presence of debris or excessive clutch material in the strainer can affect the solenoid's performance. It's essential to diagnose these potential causes thoroughly to identify the root issue and implement the appropriate repairs. When DTC P2821 triggers, several symptoms may manifest, affecting the driving experience. First, drivers may notice reduced engine power due to the fail-safe function of the transmission, which limits torque to prevent damage. This reduction can be particularly noticeable during acceleration or when attempting to shift gears. Additionally, shifting problems may arise, including harsh shifts or slipping, as the solenoid fails to manage hydraulic pressure effectively. Drivers may also see warning lights on the dashboard indicating a transmission issue. Recognizing these symptoms early can assist in diagnosing the problem more quickly, reducing the risk of further complications. The first troubleshooting step involves warming up the engine to its normal operating temperature. This step is crucial as many diagnostic procedures assume that the engine is fully warmed, allowing fluids to circulate properly and providing accurate readings during testing. To confirm that the engine has reached this state, ensure that the radiator fan engages, indicating that the coolant has heated sufficiently. When the engine is at the correct temperature, it ensures that the transmission fluid is also at a temperature where it can be effectively analyzed. This step is vital for avoiding misleading diagnostic results that could arise if the engine and transmission are not at operating conditions. In the second troubleshooting step, verifying the transmission fluid level is essential for proper transmission function. Low or contaminated fluid levels can lead to inadequate pressure regulation, resulting in the symptoms associated with DTC P2821. Inspect the transmission dipstick to ensure the fluid is at the recommended level. Additionally, check for any fluid leaks around the transmission and the surrounding areas, as these can adversely affect the hydraulic pressure and transmission operation. Repairing any identified leaks may prevent potential damage and ensure that fluid is circulating properly. Addressing fluid-related issues early in the diagnostic process is critical for achieving accurate results. This step involves draining the automatic transmission fluid, ATF, through the strainer, which serves a critical function in maintaining the transmission's health. During this process, attention should be given to the strainer for signs of metal debris or excessive clutch material, which indicate potential internal damage or wear. If the strainer contains metal particles, it suggests that there might be significant wear in the transmission components, necessitating a transmission replacement. Conversely, if no debris is found, changing the ATF becomes imperative to ensure that any contaminants are removed, allowing for optimal performance moving forward. This comprehensive inspection helps determine the overall health of the transmission and informs further diagnostic steps. In this step, blocking the rear wheels and securely raising the front of a vehicle is essential for safe access to the transmission components during testing. Ensuring that the wheels can rotate freely is necessary to perform certain tests that may require the vehicle to be in gear. When locking the rear wheels, use appropriate wheel chocks to prevent any movement. Raising the front also allows for an unobstructed view and access to the transmission and engine components, which may be involved in the diagnostics of the line pressure solenoid valve A. Always utilize jack stands after elevating the vehicle to prevent any accidents or damage during further diagnostic processes. Turning the ignition switch to the on-to position is necessary before performing further diagnostic tests. This action powers the vehicle's electrical systems, allowing the use of the Honda Diagnostic System, HDS, for real-time data retrieval and analysis. It's crucial to ensure that the engine is not started during this step, as the focus is on generating data and sensors readings at an idle state. In this mode, various electronic modules are activated, enabling communication with the transmission control units. This preparation facilitates a thorough diagnostic examination of the hydraulic systems and components involved in the operation of the line pressure solenoid valve A. Once the ignition is in the on position, the next step is to clear the DTC with the Honda Diagnostic System, HDS. This step resets the diagnostic codes recorded in the Powertrain Control Module, PCM, which is essential for conducting accurate diagnostics afterward. Clearing the DTC also allows for fresh data readings during subsequent tests, eliminating any prior faults that may not currently exist. The HDS provides real-time feedback and updates once the DTC is cleared, enabling observations of any immediate returning faults. It's paramount in modern diagnostics as it reassures that the technician is analyzing current operational data rather than outdated or irrelevant information. In this step, the engine should be started with the brake pedal firmly pressed. This action allows the technician to safely shift into drive without causing the vehicle to move unexpectedly. Once in D, drive, releasing the brake pedal allows transmission engagement while monitoring the operation of the line pressure solenoid valve A. It's essential for observing shifting behavior under controlled conditions to ascertain if the solenoid is functioning correctly. Technicians should document any performance irregularities experienced during this process, as it may provide insights into the immediate effectiveness of the hydraulic pressure management in the transmission. Proper execution of this step is critical for successful diagnostics following engine start procedures. The final troubleshooting step involves monitoring the accelerator pedal position, APP, sensor percentage, using the HDS in the AT data list. During this observation, it's essential to open the accelerator pedal approximately 2% and then fully release it back to 0% every 2 seconds. This test enables technicians to assess the responsiveness of the line pressure solenoid valve A in real time. According to the findings, if the line pressure switch is on when the solenoid is on and off when the solenoid is off, it indicates an intermittent failure, implying that the system is operating under acceptable parameters at that moment. Conversely, if there's a mismatch, it likely suggests a failure in the line pressure solenoid itself, necessitating replacement of the secondary valve body. This last step integrates live data into the diagnostic process, allowing for a finer analysis of system performance. After completing repairs, it is critical to conduct a final verification to ensure that the line pressure solenoid valve A operates correctly and that there are no remaining Diagnostic Trouble Codes, DTCs. This process may involve repeating some previous steps, such as rechecking the APP sensor readings and monitoring the solenoid's responsiveness to specific commands. The technician must ensure that the hydraulic pressure is properly regulated under varying operational conditions, as indicated by the HDS. Performing a road test may also be beneficial to confirm that the vehicle operates smoothly without any symptoms associated with DTC P2821. Confidence in the repair and system functionality is essential before returning the vehicle to the owner, allowing for proper operation and safety. Preventive maintenance plays a crucial role in ensuring the longevity and performance of the automatic transmission system in the Honda Odyssey. Regularly checking the transmission fluid levels can help detect any potential issues before they escalate into significant problems. It's advisable to follow the manufacturer's recommended service intervals for changing the transmission fluid and filter to maintain optimal hydraulic pressure and system health. Regular inspections can also help identify potential wear on components such as solenoids early on, allowing for timely replacement. Educating vehicle owners about transmission care, including avoiding overloading and using the vehicle within its specifications, can significantly contribute to preventing issues such as DTC P2821 from occurring. In conclusion, understanding DTC P2821 and its associated symptoms is critical for diagnosing and repairing issues related to the line pressure solenoid valve A in the Honda Odyssey from 2011 to 2017. By following a systematic troubleshooting approach, including checking fluid levels, inspecting the solenoid, and using the HDS for diagnostics, technicians can effectively identify the root cause of transmission issues. Addressing potential failures through proper procedures not only resolves the immediate problem, but also minimizes the risk of future complications, ensuring the vehicle operates smoothly. Preventive maintenance should not be overlooked, as it plays a vital role in maintaining the health of the transmission system. Following these comprehensive steps helps achieve a complete and effective repair. Please like and subscribe to the channel. See you next time.